So hello, good day. This is our fourth video. This video is all about the point biserial. So by definition, point biserial is used to measure the strength and direction of the association that exists between one continuous variable and one dichotomous variable. So our situation is to determine whether there is an association between the test scores of the students with their gender. So the gender would be our dichotomous variable, male or female, and the test score will be our continuous variable, 50 items. So respondent 1, male 0, he got 29 out of 50. Respondent 2, female, which is 1, she got a perfect score. Respondent 3, male, he got 45. Respondent 4, male, he got 47, and so on and so forth. So we have here 50 sample data. So let's proceed to the calculation. We are now in the point biserial correlation calculator. So you had already posted the x or continuous variable, which is the test scores, and the y or dichotomous variable, which is the gender. So let's calculate. Okay, so here are the results. So we have r is equal to negative 0.04785. So meaning to say, since it is less than positive or negative 0.25, there is an extreme or extremely weak correlation between the x and y variable, between the gender and the test scores. So the value of r is 0.04785, and the p-value is 0.74114, meaning to say the result is not significant at p is less than 0.05. So to sum up the results, we have here the narrative discussion. Objective: is there a significant correlation between students' gender with their test scores? Null hypothesis: there is no significant correlation between the students' gender and their test scores. Condition: significance level set to 0.05. R value is equal to negative 0.04785, which is extremely weak association, and the probability value or the p-value is 0.74144, and thus the decision is to accept the null hypothesis. Data analysis: the data had been tested, point biserial correlation to measure um, and determine whether there is an association between the student's gender with their test scores. The computed R value is negative 0.04785, which suggests that the student's gender and their test scores is extremely weak in terms of correlation. The computed p-value 0.74144 also suggests that the result is not significant at p is less than 0.05. Further analysis shows that the null hypothesis is true, which indicated that there is no significant correlation between the student's gender and their test scores. Therefore, the null hypothesis is accepted.